start.
Hi everyone, my name is Pinjen, and today I want to talk about the association between the fish, Cryptocentrus, and the pistol shrimp that called Alpheus, djiboutensis in artificial burrows. This one is Alpheus shrimp, and it's also called pistol shrimp. And it's almost blind, so they dig holes in the sand and share the burrows they dig with the guppies fish. So
Talk to the microphone.
So as the exchange of the shelter, the guppies fish helps the shrimp to against the predator by being the alarm system to the shrimp. It's like the eyes of elf shrimp. And this is a mutually beneficial partnership that were generally accepted by people. So why we still have to do this experiment? Both the behavior in the field and in aquarium has been observed many times, but no data about the behavior inside the barrel has been recorded. So our purpose is to record the behavior between guppies and pistolfish inside the barrel. This is our material and method. We put one fish and two shrimps into the aquarium and feed them the living toothpaste and hide the dry food for tropical fish. So this is our aquarium look like. There are an artificial barrel that was made by a plastic tube that will cut half along its axis. It's about 55 centimeters long, and the width is about 3.5 centimeters. And the water temperature is 22 degrees Celsius. And before the behavior, I will introduce inside the barrel. I will first introduce the body structure of the Alpheus shrimp. This is the Alpheus shrimp, and these two are its antennae, and this is the abdomen of the shrimp. Abdomen means the belly of the shrimp. And the first 5 legs are the walking legs, and the first 2 were specialized into the cheek. And the last 5 legs are the swimming legs called Karplus. So there are 3 different types of digging behavior of the fish of the shrimp inside the barrel. The first one is the rapid movement of the Karplus with an abdomen directed toward the entrance of the barrel. These are used to accumulate the sand into a pile. And when the sand was accumulated into a pile, the shrimp will push the sand by its chelae toward the entrance. The second one is digging with the first pair of the chelae. This is used to insert the chelae this was used to loosen the sand by inserting the chelae into the vertical sand and twitching. And the shrimps place chelae together like a plate to push the sand out of the barrel. And there's a video you can see that he insert his shell into the sand and push it out of the entrance. It just keep pushing, and you can see that there's some sand that was stuck on its shell because there are a lot of hairs on its shell. This is used to increase the efficiency of transporting the sand. The last one is dig with the second pair of the shell and the working legs. This activity was a shell digging and was used to uncover the fruit. Both inside and outside the barrel can see it. The next behavior is the behavior outside the barrel. You can see that when the shrimp is outside the barrel, it keeps one antenna in contact with the fish. So because the antenna contact is the key to transfer the information from the fish. And this is the numbers of the contact times in different parts of the fish. You can see that the contact with the tail area was more often than the contact with the head area. And the fish reacts to the antennal contact by the tail. While antennae maintain contact with the fish, the tail undulation were followed by the appearance of the shrimp from the barrel. So, to investigate the retreat response of the fish and the shrimp, we use a metal rod to be a simulation, and we approach the animals in the same angle and distance and speed. This is a chart of the mean value of 20 tests. The horizontal axis is the time, and the vertical axis is the distance from the barrel entrance. And this line, lower than this line means the fish and the shrimp is in the barrel. So we can see that when the stimulation comes, the fish turn into the barrel immediately and with the head enter first. And then the fish turn around in the barrel and began to move back toward the entrance. In contrast, the fish and the shrimps always enter the barrel by tail first. And in this experiment, we also observed that the deeper the shrimps have been inside the barrel, the less it retreats. And in the experiment, we also found some phenomenon like fish turn and head entry into tail entry. And the retreat distance of head entry is much deeper than that of the tail entry. And this represents the retreat response to the series of stimuli decrease in intensity. The correlation of the partners when outside the barrel has an obvious advantage for the shrimp, but inside the barrel is less apparent. So we think that in the barrel, the dependence of the shrimp on fish is merely a continuation of its behavior outside the barrel. And what would happen if we remove the fish from the barrel? That's the result. The shrimp did not leave the barrel before the food was given. And the shrimp dropped the sand and at the entrance without coming out. So the entrance was nearly blocked, and in the absence of the fish, the approach of the rod has no effect on the shrimp. When the fish came back, the behavior of the shrimps towards the fish was as usual, but the fish stayed longer in the barrel than usual. So this might mean that the removal of the fish had the stronger influence on the fish. And the cleaning of fish by shrimp also observed in our experiment. The cleaning of the shrimp is concentrating on the head region, especially around eyes and mouth. And the second pair of traps was used for cleaning. And this always stopped by the fish moving away. And this is the first record of cleaning fish in Alpheus. Our conclusion. Other observations in the field and in artificial barrel shows similar association behavior of the copyfish and the shrimp. So we suppose that this associative behavior can be generally applied to other copyfishes associated with pistol shrimps. Thank you.
Okay, 11 minutes, 52 seconds. Hey. Charlie. Sherry. Tina. Okay. Hey.
Could you turn to the page that the head entry differ and tail entry?
This one?
Yeah. What does that actually mean? The phenomena you observe?
Oh, we do the experiment many times. The previous response of the fish is head entry, until the end of experiment, fish usually use tail entry as the response to the stimulation.
So that's your reply. Next is Charlie.
How long have those shrimps been raised?
9 months. Both the fish and the shrimps were kept in that aquarium for 9 months.
Sherry.
What's the association between the 3D waves and sperm result? What's the association between the 3D waves and your results?
I think in this research there's no association behavior of the digging inside the barrel. It says that inside the barrel the correction of the pollen is Karplus. So I think there's no association when the shrimp is digging inside the barrel.
Tina.
Did the line of the profile affect their behavior? Did the line of the profile affect their behavior?
I can't understand.
Okay. affect their behavior?
Our aquarium is put in a dark room, which is no light, and we put a light on the top of the aquarium. So, and to avoid the disturbance of the fish, so we change the light into the dark gray light at night.
Volunteer question, Annie? Volunteer question? No? Okay. Okay, so Pinjen, I think you have chosen a very interesting topic, and in theory you could have presented in a more interesting way. Yeah, it is very possible. It's easy because the topic itself is interesting, and but the main weakness of your talk one is you are not familiar enough with your script, right? So especially at the beginning, you were like looking at the script. So I hope that next time you can improve this part. Okay. And then the slides are with it, so with many pictures. But I think the main weakness, one of the weaknesses, the 3 slides. So did you use the font intentionally? Intentionally, 故意的。
它是
No.
no.
So okay, so the first thing is, of course, when we look at the slide, we wonder, oh, that's weird. Okay, and then the next thing is it's really wordy, a lot of text, and last thing is actually this the 3 slides, the information here is not the most important message of the slides. So I suggest that the easy way that to present the 3 slides is to use your body language.
Okay.
So then you can easily just present it, if you still want to present it, because you didn't speak over time. So you can present it, but avoid this long text, use your body language. And then usually with students who have chosen such interesting papers, I always told them, you try to humanize these animal partners. This will make your story more humorous. You understand? Humanize the plot. Okay. And another weakness of your results slide is light here. I think this occurred at least 2 times. When you talk about the observation. Then you say one sentence about your interpretation, but you didn't print your interpretation on your slides. I remember these slides and another slides, maybe next slides or others. You always say, this suggests or something like that. And then that sentence was always missing. So you should always print observation and then maybe with an arrow. With an arrow. With an arrow. This means, or that would be your interpretation. Okay. And then last thing is about your conclusion. This conclusion can be more specific. For example, here you just say, oh, this similar things has been found. You conclude such a thing. So that will be uninteresting. Okay, that means we don't need your study. So I think you should conclude what kind of behaviors have been observed, instead of saying this has been shows similar association behavior. That's uninteresting. So like the antenna touch the belly of the fish and so on. That would be interesting. Okay. Well, this is an interesting talk, and I hope to see you in group the next time. Let's thank. Next week we have Rich, Chris, Kevin Liu, and Sally.
Thank you.